Good morning students. In this session we will discuss about the reduction formulae. So before we discuss the reduction formulae, let us emulate reduction formulae through an example. So today's session is reduction formulae. So there are many functions whose integrals cannot be reduced to one or the other known standard forms. So in that situation, this reduction formula is used. For example, x cube into e power 5x dx. So this is the product of two functions, as you know, and as far as the product of two functions are concerned, we will use the integration by parts. Here x cube is the algebraic function and e power 5x is the exponential function. So isolate. So first function is x cube and second function is e power 5x. So this is equals to first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to x cube e power 5x derivative integration is e power 5x by 5 minus d by dx of x cube is 3x square into e power 5x derivative is e power 5x by 5 dx. This is equals to x cube into e power 5x by 5 minus 3 by 5 is a constant. Let us separate it from the process of integration. X square into e power 5x dx. Again, this is product of two functions. So again, the process of by parts is used for the second time. But if you see, x cube x to the power of 3 has been reduced to x to the power of 2. So actually this is getting reduced, hence the name reduction formula. So x cube into e power 5x by 5 minus 3 by 5, again first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this 3 by 5 is being multiplied as a whole. So this is equals to x cube into e power 5x by 5 minus 3 by 5 into, this is x square e power 5x by 5 minus d by dx of x square is 2x into e power 5x by 5 whole dx. So this is equals to x cube e power 5x by 5 minus 3 by 5, 3 by 5, 5 5 is 25, x square e power 5x minus into minus plus 3 2s are 6 by 5 5s are 25 integral x e power 5x dx. See, x square is further reduced to x to the power of 1, reduced. So again, so x cube e power 5x by 5 minus 3 by 25 x square into e power 5x plus 6 by 25 into first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is x cube e power 5x by 5 minus 3 by 25 x square e power 5x plus 6 by 25. So 6 by 25 into x, integral e power 5x dx is e power 5x by 5 minus d by dx of x is 1 into integral e power 5x dx is e power 5x by 5. This is whole dx into this. The final answer is x cube e power 5x by 5 minus 3 by 25 x square e power 5x plus 6 by 25 5 sets 125 x e power 5x. So e power 5x by 5. So plus into minus is minus 6 by 25 5 125 integral e power 5x dx is e power 5x by 5 again. So 625 e power 5x plus constant of integration c. So what I mean to say is integral x cube into e power 5x dx. So we have to do the integration by parts for thrice. First x cube e power 5x, it has been reduced to x square e power 5x and it has been further reduced to x e power 5x. But if we know integral x power n into e power ax dx, for example, then we will prepare one formula. So that is said to be the reduction formula, and simply substitute in n is equals to 3, and then actually we will be getting now reduction formula for integral x power n into e power ax dx. Just now we have seen x cube e power 5x. So a is equals to 5 and n equals to 3 there. So let us find the reduction formula for this, and whatever the answer ultimately we are going to get, simply substituting n equals to 3 in that and a is equals to 5, then we will obtain the reduction formula for x cube into e power 5x dx, which we have done earlier. So let we will take in x power n into e power ax dx. So this is equals to x power n is the first function since it's an algebraic function into e power ax dx minus integral of d by dx of x power n into e power ax dx whole dx. X power n into e power ax by a minus d by dx of x power n is n into x power n minus 1 into e power ax by a dx. So this is x power n into e power ax by a minus, here n by a is constant, let us separate it from the process of integration, x power n minus 1 into e power ax dx. So this is equals to x power n into e power ax by a minus n by a into, so integral x power n into e power ax dx is in, then integral x power n minus 1 into e power ax dx is in minus 1, and this in minus 1 is further connected to in minus 2. So by successive reduction we will be getting I naught ultimately. So I naught is equals to, so this is x power 0 into e power ax dx. So x power 0 is 1. So integral e power ax dx is e power ax by a. So simply substituting n is equals to 3 and a is equals to 5. So we will get the integrand for this using this reduction formula easily. What I mean is This formula can connect an integral with another one which is of the same type with a lower integer parameter which is relatively easier to integrate. So if you are asked to find out the integral for integral sine square x dx, so with some little efforts actually we can solve this. How? Sine square x can be written as 1 minus cos 2x by 2 whole dx. So from this onwards actually we will know how to find this integral sine square x dx. So if you are asked to find out sine cube x dx, then actually this is we know sine 3x value, 3 sine x minus 4 sine cube x. So from this 4 sine cube x is equals to 3 sine x minus sine 3x. So 4 sine cube x is equals to by 4. So this sine cube x I am replacing here 3 sine x minus sine 3x by 4 whole dx. From this onwards we know how to evaluate this, because what sine power sine x sine 2x plus 3 sine of 100x, so sine followed by a linear function, we know how to do that. But actually if sine is in terms of power, so sine cube x, sine 3 sine power 4x, sine power 10x, etc. For example, sine power 4x, this can also be done in sine cube x into sine x dx. And sine cube x can be written as 3 sine x minus sine 3x by 4 into sine x. Again sine x into sine x, sine square x, and sine 3x into sine x we get here. So therefore to proceed from here we will have some complexity to solve this. And if you are asked to find out sine power 6x dx, then the complexity to evaluate this is further increased. So exactly to just solve this, we will prepare a reduction formula for sine power nx dx. Sine power nx dx. So actually after evaluating this we will get a formula. So that formula is a reduction formula. Why? Because power n is further reduced to n minus 1, power n minus 1 will further connected to I n minus 2, etc. Therefore it is getting reduced, and whatever the formula ultimately we are going to get is used to evaluate the integrals whose power is power 6x, power 8x, power 10x, etc. So whatever the reduction formula that we are going to obtain through evaluating this is used to find out the integral sine power, whatever the power it is, easily. So let us evaluate integral sine power nx dx. Sine power nx dx where n is greater than 2. N is an integer which is greater than 2. So let us consider this integral sine power nx dx to be in. So sine power nx can be written as sine power n minus 1x into sine x dx. Sine power nx dx I have written it to be sine power n minus 1x into sine x dx power 1. So bases are equal, exponents are to be added, n minus 1 plus 1 is n only. So here let us take this to be the first function and this to be the second function. First function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to sine power n minus 1x. Integral sine x dx is minus cos x minus Now this is d by dx of sine power n minus 1x. That means sine x whole power n minus 1. So sine x, let us treat it as x. So x power n is n into x power n minus 1. So this power will come forward. So that is n minus 1 into sine x whole power n minus 1 minus 1. So n minus 2. So this is n minus 2x into d by dx of, since sin x is treated to be x, so sin x is to be differentiated later, into d by dx of sin x. So integral sin x dx is minus cos x, integral sin x dx is minus cos x, this is dx. This is equals to minus sine power n minus 1x into cos x minus into minus plus this n minus 1, since it is a constant, let us separate it from the process of integration. So this is sine power n minus 2x into d by dx of sin x is cos x into this is cos x dx. D by dx of sin x is cos x. This cos x I have written same. So this minus I have multiplied with this, minus into minus plus. So plus I have written n minus 1. This is the constant, I have separated it. So this is equals to minus sine power n minus 1x into cos x plus n minus 1 integral sine power n minus 2x. Cos x into cos x is cos square x. Cos square x can be written as 1 minus sine square x dx. So this is equals to minus sine power n minus 1x into cos x plus n minus 1. So this is sine power n minus 2x into 1 is sine power n minus 2x minus sine power n minus 2x into sine square x. Bases or, so this is sine x whole power n minus 2, sine x whole square. So bases are equal, exponents are to be added. N minus 2 plus 2 is n. So this is sine power nx dx. So this is equals to minus sine power n minus 1x into cos x plus n minus 1. So this is integral sine power n minus 2x dx. This is I n minus 2. Because if integral sine power nx dx is treated to be in, so sine power n minus 2x dx will be treated as in minus 2. Sine power n minus 1x dx is treated to be in minus 1. So plus into minus is minus n minus 1. This is integral sine power nx dx, which we have taken it to be in the first step. So this is all in. So in, this minus, if you transpose onto another side, plus n minus 1 in is equals to minus of sine power n minus 1x into cos x plus n minus 1 in minus 2. So if you take in as a common, if you take in as common, then 1 plus n minus 1. So 1 gets cancelled. So this is whole n into in. This is whole n into in. So n is being multiplied with in. If you want in, therefore in is equals to this n. You transpose onto another side, it is going to divide both of them. So therefore minus sine power n minus 1x into cos x by n plus n minus 1 by n in minus 2. So this is the reduction formula for integral sine power nx dx. On successive reduction, if n is equals to 0, then we will get I naught. If n is odd, we will get I1. So this formula, this reduction formula is applicable as long as n is greater or equals to 2. N equals to 2 or n is greater than 2. But here I0 and I1 0, 1 or less than 2. Therefore, whatever the reduction formula that we get at the end of this will not be applicable because 0, 1 or less than 2, not greater or equals to 2. So therefore, sine power 0x dx, anything to the power of 0 is 1. Integral 1 dx is x. I1 sine power 1x dx. So this is integral sine x dx, which is minus cos x. Which is minus cos x. So this is the reduction formula. So therefore, if we are asked to find out integral sine power 8x dx, only thing is n is equals to 8, you simply substitute here and actually it will kept on reducing until we get either I0 or I1. As far as I0 is concerned, it is x, I1 is concerned, it is minus cos x. So this is how this reduction formula is applicable, and this is the use of this reduction formula. Let us evaluate the reduction formula for tan power nx dx. Reduction formula for integral tan power nx dx where n is an integer greater than or equals to 2. So if we know integral tan power nx dx reduction formula, then whatever we are given to find tan power 10x, tan power 18x, etc. So actually by using this reduction formula, simply substituting n is equals to 18 or n equals to 10, so we will get the reduction formula easily. Integral tan power nx dx. Let us suppose this to be in. So tan power nx dx, let us take it as n minus 2x into tan square x dx. So this is first function and this can be written as integral of tan power n minus 2x. We know that secant square x minus tan square x is equals to 1. So secant square x minus 1 is equals to tan square x. Therefore, tan square x can be replaced as secant square x minus 1. So this is secant square x minus 1 dx. So this is tan power n minus 2x into secant square x dx minus tan power n minus 2x into 1 is tan power n minus 2x dx. So this is of the form f of x whole power n into f dash x dx, because tan x derivative is secant square x. We have the result integral f of x power n into f dash x dx, f of x whole power n plus 1 by n plus 1. So if you don't know this result directly, then no problem. Tan x is equals to t, secant square x dx is equals to dt. So t power n minus 2 dt. So t power n minus 2 dt is t power n minus 2 plus 1 by n minus 2 plus 1. So t power n minus 1 by n minus 1. So this is tan power n minus 2 plus 1 by this minus, since integral tan power nx dx is in, integral tan power n minus 2x dx will be in minus 2. Simply this is the reduction formula for tan power nx dx. And if you are asked to find out tan power 10x, simply substitute n equals to 10 here, we will get it. And if n is even, then by successive reduction we will be getting I0. If n is odd, for example tan power 11x, so n equals to 11 there, then after successive reduction we will obtain I1. So this reduction formula is only applicable as long as n is greater or equals to 2. Since 0, 1 or less than 2, so let us substitute directly in this. Tan power 0x dx, anything to the power of 0 is 1. So integral 1 dx, which is x. So tan power 1x dx. Integral tan x dx is log mod secant x plus constant of integration c. So this is the reduction formula for integral tan power nx dx. So if we are asked to evaluate integral tan power 6x dx, so what is the reduction formula for tan power nx dx, which we have reduced right now? Tan power n minus 1x by n minus 1 minus I n minus 2. So here n is equals to 6 even. That means after successive reduction we will obtain I naught, and you know I naught is equals to integral tan power 0x dx. Anything to the power of 0 is 1. So integral 1 dx, which is x. So let us do this. So integral tan power 6x dx is equals to tan power, substitute n is equals to 6 here. 6 minus 1 is 5x by 5. 6 minus 1 is 5 minus I. 6 minus 2 is 4. Tan power 5x by 5 minus I4. So here 4 is greater than 2. This is n greater than 2. So 4 is greater than 2. So still this formula is used. Tan power, now n is equals to 4. Substitute here. 4 minus 1 is 3. So tan cube x by 3 minus I. 4 minus 2 is 2. So tan power 5x by 5 minus tan cube x by 3 minus into minus plus I2. So it holds this formula again because n equals to 2. So tan power 2 minus 1 is 2 minus 1 is 1. So tan power 1x, that is tan x by 2 minus 1 is 1. So tan x by 1 is tan x minus I. 2 minus 2 is 0. So tan power 5x by 5 minus tan cube x by 3 plus tan x minus 0. So 0 is less than 2. Therefore this formula cannot be used. So let us substitute directly in this. I naught is equals to tan power 0x dx. Anything to the power of 0 is 1. Integral 1 dx is x. So I naught is x plus constant of integration c. So this is how we will use this reduction formula to simplify the given integrand with whatever the power it is easily.